Hello students, today we will discuss about the power which is related to topic. Our topic is AC circuits, so AC power. So in the last previous unit we discussed about the DC power. So in the DC power, directly power is volt amperes, and in the DC power, active power, these powers both are same because their cos phi is 1. But here cos phi is not always 1, power factor is varied. So that's why here require the more explanation compared with the DC power. Here AC power, look at here, AC power is, you know that the electrical power is multiplication of voltage and current. So first the power calculated as apparent power represents with the symbol of S. It is nothing but voltage into current. The units are, voltage units are volt, current units are amperes. This apparent power divided into two types. One is active power and another one is reactive power. This active power is called, another name is the real power. Another name of active power is the real power. It represents with the symbol P. The reactive power, another name is imaginary power. Imaginary power. So why it is called imaginary power discussed in the next topic. In this topic we will discuss that. Here Q. This real power formula is VI cos pi. For VI we are multiplying with the cos pi. This cos pi is a factor, call it as the power factor. In every AC electrical circuits, when the power is transferred from source to load, depends on the circuit parameters, the power factor will comes into the circuit picture, then that will decide the power. So that's why VI cos pi is real power. The reactive power is VI sin pi. The name is imaginary power. Now about units. So first, active power units are watts. We are paying bill for this, watts. The reactive power units are simply volt ampere reactives. Volt ampere reactives. General volt amperes. This is reactive power. That's why we will get reactives here. This is reactive power. We will get the reactives here. But here directly watts. Directly watts. Up to now, you know, I think you have all idea about all the terms related to power. Except one parameter, that parameter is cos pi. Cos pi, the name of the cos pi is the power factor. Power factor, that means where is the power is there, it is multiplied with some factor. Look at here, here the active power is multiplied with some factor, that factor is cos pi. That's why it is the power factor, right? The symbol is cos pi. Power factor is, symbol is cos pi. What is phi? Phi is, here phi is angle between voltage and current phasors. Voltage and current phasors. That means voltage have some phase difference, current has some phase difference. It shows the difference between voltage and current phasor. Difference between voltage and current phasor, right? Here, that's why cos pi. It is cosine angle between voltage and current. What is cosine angle? Angle is phi, cosine phi, cos phi. It is cosine angle between voltage and current. This is the cosine angle between voltage and current. Look at here. This is voltage and phi means angle between voltage and current. Cos phi, actually cos phi is some, generally phi is some angle, it is multiplied with cos phi, it become as a magnitude, constant values. Generally cos phi value is, if you take the any angle, that cos phi value is always 0 to 1. That's why 0 to 1. So that is the reason it doesn't have any units. It doesn't have any units. For example, voltage has some 0 phasor, current has 30 degrees phasor. That means this meaning is we can write like this. This meaning is voltage at an angle of 0, we can write like this. Then another is current is lags means downwards, which lags means minus 30. Then the angle between the current and voltage in minus 30 minus 0, then cos 30. That value is 0.866. Now you understand? Right. But that cos pi in reactive power, it will be modified into the sin pi. This is important. In every problem we have to discuss the cos pi. The reason is it is involved in the active power. Right. Once again, the power factor it is the cosine angle between voltage and current. Right. Already we discussed about the waveforms. Next, we will prove apparent power is nothing but combination of active power plus reactive power. We have to prove this. For that, here generally active power, if you look at here, active power is the real power and the reactive power is imaginary power. That's why I am writing always apparent power equal to, in terms of vector, active power plus J into reactive power. Why? Reactive power is imaginary, it is a real power, real value, imaginary value. That's why S equal to P plus J into Q. So this is apparent power is V into I, active power formula is VI cos pi, reactive power formula is VI sin pi. Then so if you want to, this is actually real power and reactive. In order to getting the magnitude, so you have to find out the magnitude, this term real term square plus imaginary term square, we will get the magnitude. That's why VI cos pi whole square plus VI sin pi whole square under root. So both the terms V square I square is common. If you find out outside, VI common, remaining part cos square pi plus sin square phi, then VI equal to VI. Understand? So that is the classification of different power in AC power. Simply, the power is apparent power divided into active power and reactive power. Active power have cos pi, reactive power has sin pi. That is the relation between the active power and reactive power. But in case of DC power, so just we will discuss about DC power, simple analysis. Then you will clearly understand. DC power. In the DC power, the first power is, so generally first any power have any DC power or AC power, first is the apparent power. Apparent power units are V into I. Again that power is divided in two powers, one is active power and another one is reactive power. Active power and reactive power. Now we will find out only here apparent power is active power, both are same. Generally these are units are watts, but reactive power in DC power is 0. Why it is 0? We will discuss here. Look at here. Generally DC voltage waveform and DC current waveform is like this. Voltage is always, for example, like this, and current is always, we don't know magnitude, we don't know time period, but like this only. If you observe here, in the DC voltage start from 0, in DC current also start from 0. Is there any phase difference? Between voltage and current? No phase difference means phi is 0. Phi is 0 means cos phi value is 1. Understand? Cos phi value is 1. Now you have to find out the active power. Active power is VI cos pi, but VI cos pi value is 1, then it become VI, nothing but the apparent power. Understand? This AP means active power. Actually this is active power. So here active power is equal to the apparent power. But what about reactive power? So we will find out the reactive power now. VI sin pi. Where is cos pi is 0, sin pi value is simply cos pi is 1, what about sin pi? 0. Reactive power is 0. Now you will understand very clearly why in the DC circuit we have only active power. That's why apparent power, active power both are same. Reactive power is 0. That is the reason we are not discussing about the reactive power. But here we have every time in between voltage and current we have some phase difference. We don't know, depends on load. In order to calculate the exact power, we have to follow this procedure. I think all of you understand regarding this AC power and difference between the AC power and DC power. Okay, right. Now we will discuss a problem. Now we will discuss problems related to the power. So by doing these problems, you will understand. So exact what is AC power, what are the different types of powers. Right. The first problem, a source having V 100 sin omega t. Always AC in terms of sin omega t. DC doesn't have any signs, directive value. I equal 20 sin omega t minus 30. I supplying to the circuit. So we have some source. We don't know actually what is it. It is a source. He is given voltage and he is given the current, and it is supplying to some circuit. We don't know this circuit actually. This is circuit or load. Yes. Find A. First, the power factor. Second, active power. Third, reactive power. Fourth, apparent power delivered to the circuit. What are the powers? This is the source. From the source, what is active power, reactive power and apparent power delivered to the load. So first you have to write down given data. That is, first you have to write down the given data. That is, first voltage value, just write the voltage 100 sin omega t, and the current value is 20 sin omega t minus 30. From that you have to compare with the instantaneous voltage and current. What is instantaneous voltage and current? V equal to Vm sin omega t and I equal to Im sin omega t. If is given like this, you have to take phi. If he is not given any phi, directly omega t, just for my comfort. Right. From that, first you have to find out the power. Just you find out RMS values, because RMS values are the only effective values to calculate the power. Just keep in your mind. Wherever AC errors is given, if he has to find out the power, then you have to use the RMS values only. That's why you have to find out the RMS value. From this, you know that what is Vm? Vm is 100. Then what is RMS value? Vrms is 100 by root 2. 100 by root 2. The value is 70.71. But there is no phase difference actually. Look at here, there is no phase difference. So you can like this, Vrms magnitude at an angle some any angle at an angle of 0. Simply this is the magnitude, 70.71 is the magnitude at an angle of 0. At an angle of 0. Then same procedure you have to follow for the current also. For that, just from this equation, what is current? Peak value or maximum value current is 20. Just 20. From that, the RMS value is what is RMS value? Peak value by root 2. Peak value by root 2. What is peak value? 20 by root 2. So what is that value? That value is, by doing the calculation, 14.14, but 14.14 amperes. But you have to write IRMS. He already given some angle phi. He already given at an angle, voltage has at an angle, that is IRMS at an angle phi. RMS value is, just write down the magnitude, 14.14 is the magnitude. What about angle? Angle is phi. Phi value is 30. You can take plus 30 or minus 30, anything. So voltage is like this and current is like this. Current is like this. First you have to find out the RMS voltage and RMS current. Then what is first question? First question is find out the power factor. First question is to find out the power factor. Right. First question number A is power factor. What is power factor actually? Power factor is represented with cos phi. What is phi? It is angle between voltage and current. You know, directly you can find out power factor, but you have to remember this. Just generally voltage is, what is voltage waveform? 70.71 at an angle of 0. What is current waveform? This is the current waveform value is 14.14. This is by lagging 30 degrees. So at an angle of minus 30. Directly what is the angle between both voltage and current is? Directly you will get phi value is 30. Then what about cos 30? Cos phi power factor equal to cos 30. Cos 30 means root 3 by 2. Simply cos 30 equal to root 3 by 2. Is it 0.866? Any units for power factor? No units, because it is constant. Next, second thing, active power. What is the formula for active power? So first you write the active power. Active power represents with P. The formula is VI cos pi. But you have to keep the mind, what is V, what is I? V means, just most important thing, RMS value of V, magnitude of RMS value. This is magnitude of RMS value and this is the power factor. This is important note. Just keep in your mind. Don't confuse. Always we have to write direct VM. Not VM, this is VM, but you require effective value. What is effective value? Is RMS value. That's why you have to write. Just keep it as a note for any problem. Right. Just write down all things. What is VRMS? VRMS is 70.71. 70.71. And what about IRMS? IRMS equal 14.14. What about cos 30? 0.866. Then what is active power? By calculating this we will get 865.88. Units are kilowatts or watts. Next. Simple. Next, reactive power. Reactive power represents with Q. The formula is VI sin pi. Right? You know that V is 70.71. I is again 14.14. What about cos phi? You will find out, just sin phi directly, sin 30 simply. If you calculate this, you will get 499.91. What is units? Volt ampere reactives. Volt ampere reactives. Next, the last thing is apparent power. The last thing is the apparent power. Apparent power is represented with S. Don't confuse active and reactive. This is active, this is apparent. Right? Represents with S. This simply directly you can write like this. P square plus Q square. So what is P square? 865.88 whole square or 499.91 whole square. So finally you will get 999.83. What are the units? Apparent power units are volt amperes. Volt amperes. So this is a procedure when AC voltage and AC current is given in your problem. What is a simple procedure? You know everything, you know formulas, but here the conversion is important. The conversion is just he is given instantaneous voltage From that you have to find out the RMS values. First you have to find out the maximum value from here, then RMS value. Then you have to write magnitude and phasor form. Same here also, current is there, you write a magnitude form and phasor form. Then you have to use the RMS. Then in the formulas you have to use the RMS voltage and RMS current. Always you have confusion when he is given the AC supply, directly you substitute this is the 100 and 20 cos phi, like that. Don't write, just compare with this is a VM value, but in that value you have to activate RMS values and this thing. Okay, this is a simple procedure, just keep your mind, this is the important model. Okay, right. Now the second problem, the problem is an AC varying sinusoidally with a frequency of 50 Hz. AC varying means nothing but AC supply. Sinusoidally with he is given the 50 Hz, simply a 50 Hz, has an RMS value of 20, RMS value of 20 amps. He is given 20 amps. He is given amperes means so the given magnitude is nothing but current, amperes. So that's why I am taking the 20 amperes. Write down the equations for the instantaneous value. The question is he is asking to find out the instantaneous value, that means I of omega t, simply I of omega t. This is first question, and find the instant value at 0.025 second. At this second, the second question is he is asking to find out I of omega t at which time? 0.0025 second, one thing. Next, third thing, next question is 0.0125 second. The t, third is I of omega t. He is also find out the I of, he is asking to find out the I of omega t, but t is, here the t is 0.0125 second, 0.0125 second. Yes, so these are the currents at particular times, at which time and this time. And next, after passing through the positive value, at what time the positive maximum value will be, instantaneous current will be 14.14. So this will be discussed later. First we will discuss all those things. He is given frequency and given RMS value, right? If he is given frequency, simply we can find out omega value. What is omega? He is given the frequency, but we have to find out the omega. Why we need to find out the omega? What is instantaneous value of current? The formula is like that, Im sin omega t is the formula. Sin omega t is the formula. Simply from that you have to find out the Im, you have to find out the omega. Generally here frequency is given from 50 Hz. There is a relation between frequency, normal frequency and angular velocity, that is omega equal to 2 phi f. Omega equal to 2 phi f. So that's why 2 into 5 into 50. So that is 314 radians. Omega value is 314 radians. Directly we will find out the omega. And we have to find out the another thing, that another thing is we have to find out the, we have require omega is completed and we require Im value. But in the problem he given IRMS. So what is the relation between the Im and IRMS? IRMS equal to Im by root 2. From this we can find out peak value or maximum value equal to root 2 into IRMS. So here Im equal to root 2 into, what is RMS value? 20 amps. RMS value is 20 amps. So from that we can directly write Im equal to 20 into 1.41, directly we can write 28.28 amperes. 28 amperes. Okay, clear? Clear. So what's next? The first question is, he asked to find out I of omega t is completed. So directly first write, what is I of omega t here? Instantaneous value of I equal, what is Im value? Im value equal to 28.28 into sine, what is omega? Here omega is 314. Just write this 314, and just t. This is the instantaneous value of current. Next, second thing is at t equal 0.0025 second. The question is, he has to find out the instantaneous value at this current. So first write down I value equal to, at t is 0.0025. Just in place of, you have to write here simply 28.28 sine 314 into 0.0025. 0.0025. Then if you calculate this, you will get 0.3874. 0.3874. Next, 0.3874. So third problem, directly same as this procedure. So he is asking to find out the next thing. At t equals at the time period of 0.0125 second. So you will do this very simple. Just follow this procedure, right? So it's better to write at t equal. Better to write it is t equal. Clear? Next, last thing, at what time from positive maximum value will instantaneous current will be 14.14. That means he is given instantaneous current. Instantaneous current means current I or I of omega t, both are same. So current value is directly given 14.14, and we know the peak value. What is peak value? Im value? Im value is 14.14, I think. Im value equal to directly 28.28. 28.28. Simply Im value is 28.28. And the question is, at what time the current will be this, right? So you have to find out the t value. So simply again, the instantaneous value of the quantity of the current, the formula is same formula. That formula is I equal to Im sine omega t. From that, I value equal 14.14 equal to Im means 28.28 into sine omega means 314. We have to find out the t. Understand? So we have I value is given in problem. Im value, we know the Im value. Sine, we know the omega value. But at what time he is asking, right? So from that, so simply 14.14 2 times, right? From that you have to write 1/2 equal to sine 314t. Okay? From this 314t equal to sine inverse of 1/2. Sine inverse of 1/2 means, so 314 we can write like this, that is 100 into 5 into t. 100, and simply why I am writing like this? Because we will get in terms of radians here, but 314 simply 100 into 5. 3.145, 3.14 into 100, you will get 314. So sine inverse of 1/2 means 30. Actually 30 degrees, I can write it as the 5/6. 5/6, right? So from that you can write 100 into 5 into t equal to 5/6 simply. So 5 will be cancelled. Then t equal to 1/6 into 100. If you calculate this, you will get the time period is, what is the time period? 0.0015 0.0016 second. At what time? 0.0016 second. Understand? So at time period of 0.0016 second, you will get the current value is 14.14 milliamp. 14.14 milliamp, right? So this is the reverse procedure actually. So in the previous problem, these all are mentioned, but in this problem he reversed the procedure. So he can ask two types in the examination. He can ask two types. First one is the one, second one is the second thing. So I think all of you understand these things. Don't confuse in anywhere. Simply follow the calculations. Then it will be very easy, very understandable. Okay. Thank you. Right.